Morning, guys. Okay, now this week we're going to cover two modules, and we're going to look at one really in particular, the other one you can prepare. The two modules being the one on distributing use case behavior to analysis classes. What does that mean? What does distribute use case behavior to analysis classes mean? To assign operations, to assign actions and things which this class now can do to the classes. So from this, you will see there's a presentation on allocating on that. And one of the things it touches on is how do we allocate responsibilities to analysis class. Okay, so things that we might need to look at is that between the actor in communication. So what we can see is that we have an actor. With what is the actor going to talk? What is he going to use to talk to the system? If we talk about an ATM and we're going to authenticate ourselves with ATM, and I take out my bank card, I go to the ATM, what would be the classes, the things that he uses to authenticate? Yes, the password ultimately will store his information, but how is he going to authenticate? What is the process? If we had to draw a sequence diagram, our actor, what is he going to use a boundary clause? Is there going to be a control clause? Will there be an entity clause? Yes, to some extent, to those. Okay. Will you have a boundary clause? Yes. So if we had to model this, okay guys, so if you develop a sequence diagram, what is the normal things that you're going to still have? You're going to have the lifelines in that diagram. What is the guy that initiates the communication? Who are they? Our actor, the user. What is he going to use to communicate with the system? The boundary clause. Okay. What is the boundary clause going to communicate to? To tell it what to do, what's going to happen next. The control clause. How's the control clause going to know, can we authenticate this person? We need to compare it to some actual data stored in the database. So what we see here is typically the lifelines which we will see. Now, the naming to this may differ based on the use case. And for example, our entity classes may even be more. Because it may not just be just one, but can also be multiple, that we retrieve information from multiple classes to do the work. Okay, so if we are going to authenticate someone, and this guy's going to a bank, what is he doing? Does the inserting of the card start the use case? Is it part of the sequence diagram? Yes. Okay. So our actor inserts his card, and it's there. What happens from the boundary clause? From that device which is now reading the card, what happens? Can that class by itself, was it supposed to make the decision, okay, this information is correct? Where's that? Where's that decision behavior? That decision behavior is in my control class. So the control class knows what must happen. How are we going to validate this? Okay. So even in this validation, it may be quite a long step. It's possibly not just a short step. Okay. So what would be one of the first things it needs to do? It needs to check, is this card working properly? Okay, what next? So then to ask this guy, okay, enter your password. And where is he entering this information? On the boundary clause. But from what I'm seeing is that we might possibly have two boundary clauses. Why two? When you insert your card, where are you inserting this information? Okay, but where do you insert your card? Answer that question.
On the card reader interface.
You see that there's a card reader, there's a small device which we're using. So when we insert the card, what we possibly need to note is that there might be an actual thing that we insert this card into the card reader. The card reader is then sending the information to the controller, and it's not the same boundary as the one which we're using to display this. So this could possibly have been modeled differently. Okay, we might have had another boundary clause in there. So we might have something like that, where the actor inserts his card into the card reader. That's a device. Because from an external device, what do you have? You have an interface. Okay? The interface then passes information to the controller. The controller then goes and sends the information to our form, the screen. What happens next? What's the actor going to do? He's going to enter his information. Okay. So as he's entering it, what is going to happen next? We're going to now pass this information back there to our controller. Okay. Note that this guy might actually be smaller because it's almost like stopping there. Okay. What happens next? Now we need to go through the authentication process. Yes, Santa. So we need to go and ask the data storage, our entity about it. Is this stuff right? Okay. So what are we seeing in our sequence diagram? Let's just go back to this. When we look at this, actors, with who are they communicating? They are communicating with some boundary clause. Now keep in mind that an actor can be a human, as an actual person, or a device, or another system. And if they are going to communicate, the actor might use a form, or they may use a device or system interface, which in essence is some kind of API allowing us to access this information. Then, from your boundary clause, you are working with what? The control clause, because they know about the behavior what we are going to have. Then we also have an entity clause which is storing the data. Okay. Now, okay. Things which I just want to point out is that when we look at the diagram, in analysis, we do not see really the returning message. What do I mean by that? When we go to our diagram, can we see the data which is being returned? Okay, so in analysis, we don't really see this. We don't focus on identifying the backwards point of data, what is being returned. We know that ultimately when we design this, the implementation of just how that data is passed back may be different. So this we don't really see in analysis. What are some other things which we can see in an analysis sequence diagram? From the walkthrough, you would see that we've identified this guy. Those blocks. What does that block tell us? There's different blocks. In the software, it will just tell it that this is an interaction use. So it allows us to have some form of interaction. Now there is different types of them. If you go to the walkthrough, there's a mention where it's talking about the fragments. Those frames are called fragments. And the software nicely mentioned the interaction uses and so on, but there's different ones. We can have an alternative, we can have options, we can have loops. So a lot of times in our diagram, we can even indicate a loop. Now, you don't always see it in sometimes loops in your basic flow diagram. But when you start to create a bigger diagram where it represents the whole use case as a repetition of what's going on, all the possible scenarios, you can start to have, for example, your alternatives and options in one big diagram. So it really becomes a very big diagram showing all the possible ways through it. Now, if we look at our ATM one, which we spoke about, the Authenticate, there's also mentioned that you can possibly go through the authentication process multiple times. What happens if your PIN is wrong?
It asks you to type PIN again.
Okay. Does it go through the same use case, the same behavior? To some extent, yes. Which behavior? This portion here from where we're displaying this information to where the PIN is being done, to where this is happening. That is repeated. Are we going to repeat the top portion where the person inserts the card? No. So what we are repeating is this portion. So this can possibly be placed in a loop. Okay. So we can have from that a loop. Now what you will see with these loops, they have a box here to the side. Then there's a name in it, which tells it what type of fragment do we have. Is it a break, is it optionals, or is it loops? And then we can also add conditions to this, telling it this loop will happen however many times. How many times should that happen?
3 times.
Okay, what is going to happen if it's more than 3 times?
To block the card.
Okay, so we might have an alternative portion here at the bottom. Okay, but if it was just a plain basic flow sequence diagram, what happens in the basic flow of the Authenticate? Is this repeated? Is this repeated in the basic flow? No. So from the basic flow, if we just go through the main scenario, what are we going to see? You won't see the interaction uses really. You will just have a diagram that goes straight through where it starts, it's doing some things for us, but you won't really have these blocks. Okay, when you're starting to pull multiple alternative flows and loops and so on together, you can start to have a bigger diagram. Okay. Any questions, guys?
So, when crafting that loop, what condition does it initialize?
Okay, so you're asking when we're creating the loop, at what condition does it initialize?
Yeah, initialize the loop. When does it start the loop?
Okay, remember that this loop is started when it still goes in The first time, so that the first iteration to this will be the method that you are displaying the form.
So rephrase it. What triggers the looping part? The looping mechanism?
What triggers the looping part?
Where the password was wrong.
Oh, okay. That's what I'm saying, is that there is actually more things in here which you might not see. The loop was almost happening with a condition. There's other portions which might go in the loop. For example, these breaks. You also have options that when something is now successful, what must happen? It must break out of the loop because it was successful. But if it was not successful, what must happen? It must continue in the loop and ask the person, please re-enter your information. But in essence, we also have one which is called a parallel frame. What happens when the person cancels the authentication? When can they cancel? At any point they can cancel. So what we're seeing from this is that it really can happen at any point in the beginning of our diagram. Some form in the beginning. At any point really. So you'll see we also have this option about parallels where it really can help us to do things in parallel. So at any point when this guy triggers the interrupt to cancel this transaction, it will jump out. It will return your card. Okay. Any other questions? Yes. You did not understand about the basic flow. Okay. When we go through our activity diagrams and we also look at our specification documents, what we a lot of times we've seen that a use case starts at the beginning. It has some form of a start. And then at some point it finishes. We can see this almost as a electronics diagram where it starts at the beginning and it goes to an earth at some point. But there is multiple flows through this. What is your basic flow? The things which is going to happen 99% of the time. What is going to happen 99% of the time with an ATM when you're authenticating? We at least hope the person enters their credentials correctly and it can read the card and you are authenticated correctly. Okay, so that will be your basic flow. What is possible alternative flows to this? Successful alternative flows. What would be a successful alternative flow?
The card was inserted, the authentication, the PIN was valid.
Okay.
That's the basic.
So that the card has been inserted. It has been validated and it's successful, and so that happened. What is alternatives to this? What about the... Okay. So we can have the matter of the card has been rejected. So a card has been rejected. Card being rejected, is that successful? No. In essence, it is a failure scenario. But what we still see at some point, we have a small portion of the basic flow. What small portion? You've entered your card. Then the next step, possibly from it will jump out and will go to the alternative flow for card rejected, because all of this will be an alternative flow, where if at this point in the basic flow, the system detects that the card is incorrect and has been rejected, what should happen then? I got it right, that I inserted my card the wrong way around. What should happen? Should I just reject it plainly and say to you, bugger off? It actually just returned me my card without giving me any message. It just returned the card.
It will say the card was inserted incorrectly.
But to me, at that point, that day, it said nothing. It just returned the card, and then I realized, oh, this card is the wrong way around. And then I switched it around and pushed it back in correctly. And then it went through. Okay, so what we are seeing, and to come back to your question, is that what we're seeing in a basic flow is a basic flow will be the flow which happens most of the time. Now, we might have other flows through our diagram also. And a lot of times when we go to sequence diagrams, when we're developing sequence diagrams, the question might even be, go and develop a card rejected scenario sequence diagram. What does that mean? How do you know what flows must be in your sequence diagram from just listening to that? How do we know? When we go to a specification document, I'm just going to jump to the one in our exercise. This was for the place order use case. Now what we're seeing for the place order use case, there was a lot of things in it. But if we go and say, go and develop, for example, the customizing order item scenario sequence diagram. How do I know what flows must be in that diagram? Is it just going to be the basic flow? No. Because from looking at my scenarios, I can now see, oh, I have a portion of basic flow, but then I've customized an item also in there. So in essence, what it means, we are having almost this. We have a portion of the basic flow, and at some point it jumps out, and it can even come back to the basic flow. Okay. So when we look at this, we might have a portion where it goes on and on and on. And at some point in your basic flow, you are making a decision as a user, or that the system is doing something which is now not part of the basic flow. So then it is going to jump to your alternative flow which handles that specific section. So, for example, customize an item. You might have gone through the whole process of ordering a pizza, let's say, for example. And then they ask you, oh, you've now selected this pizza, but do you want it thin crust or thick crust? With cheese or without cheese? Okay, so that is now not part of the basic flow anymore. It can jump out and be part of some alternative flow. Okay.
So about the messages in the sequence diagram, sequentially, should they be time related?
Okay, so in the sequence diagram, we see that there's a mention that when we're talking about messages, there's also a mention that our things are collaborating, and then when we're developing a sequence diagram, it shows to us our time ordering of messages. What do we mean by that? Can we see from our diagram here, in what sequence is these messages happening? Yes. Which message is calling which? It's almost like saying from this operation, I'm calling another operation. I cannot see the total details about the full functionality of that function or operation yet. But from it, I can now see, okay, but from this, I'm calling another one. Did I answer you? So yes, from our diagram we
When
can.
you are inserting the card, the moment where it's prompting the customer to insert the card, the message ends there and then starts a new one. It's always triggered by the customer, the new message. And
So that happens, and then it passes the information on. So it's almost like that message is starting the communication and it's continuing, passing the data on.
on, and then that
Yes.
continue on when the customer is, types the PIN there, or it ends where it says insert card or insert PIN.
Okay. Keep in mind that at some point, even what we're seeing for an object, in a lot of our language, we have a form of garbage collection. What is garbage collection?
Where variables
Are removed and they are taken out. Is this thing going to stay in memory the whole time? So what we a lot of times see is that we can even go and model the creation of an object, and when are we actually destroying this object? Okay. Now we are, at this point, really not focusing on that. This is almost independent of that. For some systems where you are looking at C and C++, you can model the creation. So by talking about creation, how can I go and say this is creating that whole lifeline, the whole from there on. And then we can also have a destruction where it says to us, so this is almost like indicating creation, and the other one is indicating destruction, meaning that we are now destroying the whole object which has been created, which we have. Okay. I have a question, guys. Okay, so what I take from this week is that you are going to have this module, which focuses more on the development of the sequence diagram for a use case. Now, from this, we've looked at how do you do it. You might take the specification document. What does it tell us? It tells us who is doing what. If we look at some of this quickly, the system retrieve the items on special. Who's that? The system. Is it the boundary class or the control class? Does the boundary class have the role of getting information, of interacting between classes? No. Which class is that? The control class. Okay, so when we look at this, the control class is going to interact with who to get the items on special? The entity classes. Okay, so you start to see, but from looking at our specification document, we are looking at who is interacting. Okay, and between what is the interaction? So if we go back to this, we also said our interaction is always going to be between the actor and the boundary class and the controller. Controller can go to the entity or the boundary. Keep that in mind. So that when you develop this, and if we look at the second one, the system displayed the order option screen. Who knows to initialize that display? Boundary. So boundary class is going to talk to who? Which class has the responsibility of displaying stuff? Which class has the responsibility of displaying information? The boundary class. So what are we going to see? Our control class is going to talk to the boundary class and say to it, oh, go forth and display some information for us. Okay. So the system retrieved the available options. Who's that? Who's doing that? The system retrieves the available options.
The controller will.
Okay, again we're seeing the controller. Controller is talking to what? Entity class, because the entity class keeps the information of possible options which the guy have to go and buy. Okay. Guys, so a lot of times we will see that the controller is the guy really sitting in the middle, and you are a lot of times seeing this. Controller is going to the boundary. Controller is going to the entity. You are really seeing that type of interaction. The controller in the specification a lot of times is almost, it says just the system. But who actually makes the system tick? Is it what is being displayed in terms of the user interface, or is it the actual logic behind the system? The logic. Okay. Any other questions? Can you develop a sequence diagram? Okay, that's good to hear me. Guys, so I hope that from all of this that you will be able to apply this and to develop sequence diagrams. Okay. Now I know that there's another module also for this week on looking and finding and looking at the qualifying the analysis mechanism. What is an analysis mechanism? Some of the mechanisms which they mean and which they talk about is to say, for example, persistence, inter-class communication. It's almost like saying, what are we going to use? And if we look at our classes, for our use case, we might have identified different classes. I might now go and say, but these classes have the following mechanisms and require the following things from me. Okay, if we look at our boundary classes, what do they require? Do they require security? Security is a mechanism. And if we talk about security, we can later go and say, but these are things which we can look at the granularity of the security, the access. You can start to specify in a lot more detail. Okay. There's a user interface also for that portion, which is related to that. If we look at our entity class, which stores the user's account or card information. Okay. One of the mechanisms which we have there is to say persistence. Persistence means what? It's going to be stored in some way. How it's stored, we don't really know at this point. We've not focused on that because we've not looked at the database, the technology which is used. But we can go and look at how much data do we need to store. Yes, the frequency of data. How often am I going to read this table? Because it has an impact. Am I going to keep it locally? Is it just on the card, or is it on the ATM, or is it at the bank actually? Okay, so it actually allows us to talk about it without really discussing the nitty-gritty details about how am I going to implement this. Okay, so that's really where the qualifying of analysis mechanisms comes to play. Okay. Okay, guys, I hope that this was informative and that you can use this information in this week. Okay. You must enjoy your morning then.